Consider the following graph. A graph is given. If you construct a graph, if you construct a depth first search tree on the given graph rooted at C, what will be the weight of the resulting tree? Given a choice between vertices, choose the lexicographically first. So here we have to construct a DFS tree by starting at vertex C. So let us write vertices first. F, D, B, this is A, this is C, this is E, this is G. We have to start at vertex C. If you see the graph, we can see that vertices D, E, B and A are adjacent to C. So we can visit any of these four vertices. But here it is given that choice between vertices, choose lexicographically first. That means we have to go when there is a choice, we have to choose them according to the alphabetical order. So we have to, after C, we have to visit vertex A. From A, vertex from A, vertices C and B are adjacent to vertices C and B are adjacent to A, but C is already visited. So we have to visit B. From B, we can see that vertices C and D are adjacent. So C is already visited. Now we have to visit D, which is of cost. The cost of path between D and B is 1. After going to D, the vertices C, E, F and G are adjacent to D. If we choose alphabetical order, we have to visit vertex E, which is of cost 10. From E, we have to go to G, which is of 7, and from G, the only unvisited vertex is F, which is of cost 9. So this is the depth first search tree. So now the cost of this tree is 6 plus 2 plus 1 plus 10 plus 7 plus 9. So 6 plus 2 8, 9, 19, 26 and then 35. So cost of this DFS tree is 35 units, which is option B.
The question, the data is there were some 5 process P0 to P4 allocation matrix and maximum is given, and total resource availability is given. So out of this available, which of the following is correct about the above system? Which of the following is correct about the above system? So we need to find out the correct statement. So first let us find out the need. Need is nothing but maximum minus allocation. So 0 to 3 minus 0 to 3, it will become 0 0 0 0. It will become 3 3 3 1. 3 3 3 1. It will become 1 4 1 1. It will become 0 0 2 0. This will be 0 1 1 0. So these are the matrix of need. Out of 3 5 5 5, what is allocated? 1 plus 2 is allocated for resource A. Then the available will be 0, and again this is 2 plus 5 6 7 8, all 8 are allocated. This is 0. 3 plus 2 5 are allocated. This is also 0. 3 plus 1 plus 1 5 are allocated. It will be 0. So now available is 0, which you can execute. We can't execute any other except the P0, because P0's need is 0 0 0. So first we will execute the P0. When P0 is executed, so for the available 0 0 0 0, the allocation of P0 will be released 0 to 3 0. Now available will be 0 to 3 0. So 0 to 3 0 is sufficient for either P3 or P4. So when P0's allocation is released, these are sufficient for either P0 or P3 or P4. Okay, for example, if you execute something like P4 for example, so if you execute P4, then 2100 will be released. So this will be 2330. These are sufficient for, not sufficient for P1 P2, it's sufficient for P3. So either P3 P4 or P4 P3 we can execute. After execution of P3 2330, then what will be released? 0301 will be released. So it will be 2631. 2631. Still what we can execute after P4 and P3? P1 and P2 are remaining. Still P1 we can't execute. Okay, shall we execute P2? Because 1 is required, it is less. So we can execute P2. After P2 is executed, then 1121 will be released. Then 3752, which are sufficient for P1. So we can have the last process that executed is P1. Before that we execute P2, and then this P0, P4, P3, P2, P1. Option D is the right option. Option D is the right option here. If a P0's request for, this is the second question, if the P0's request for 1342, for example, P0 is requesting for 1342 for example, how many more resources are needed minimum in order to grant the request? Okay, so now we have to modify the data structure. If any process is asking for resources, then need should be reduced, allocation should be increased. You have to assume that as if a request resource are allocated, what will happen? Available should be decreased. Okay, what are available earlier? 0000 is available. Okay, so if minimum number of resources are, how many are available, then this request will be granted. That's what the question is. For example, for 1342, if we have minimum 2102 for example, okay, we have to find out minimum. Okay, that means the P0's allocation, already we found that P0's allocation is 0230. If this request is added, then it will become 1342, then total it will become 1572, and the need of P0 will become decreased. P0's need is 0000, the need will be reduced. Okay, so if that means usually when it is greater than the need, then it will be terminated, but we are supposed to find out the minimum number of resources required for granting the request. So it should be a total you have to calculate. For example, these are allocated, for example, need will become 1342. Okay, then 1111 are added, then 2453 resources are available. Okay, so if 2354, you have to see that the need of all other process is less. So for this minimum, the need of all other process is less, so that 1112 we can assign. That is the minimum number of resources required. So B is the right answer here.